Hello students, the next code we are going to see is 8:3 priority encoder. So before entering into the session, please subscribe my channel VLSI with Dr. Leena. So what is 8:3 priority encoder? It is a digital combinational circuit that has 8 input lines and it produces 3 output bits. Outputs the binary index of the highest priority active line. So here what makes it priority? In the normal encoder, only one input should be high at a time. But in the priority encoder, multiple inputs can be high. But in this multiple inputs, the circuit gives more priority to the highest order input, usually most significant bits. Highest index input is equal to highest priority here. So these are the explanations. I'll give you few examples so that you will know clearly. Let's see the first example, that is IN0, IN1, 2, 3, 4, 5, 6, 7. These are all inputs we are giving. See, in the inputs, IN0 is high. That is, only the IN0 is active. So, only IN0 is active and the output is 0, 0, 0. That is the binary value of 0. So, it first checks which one is active. If only one is active, it takes it as the higher priority one and it gives the output. Now, if there are 2 or more inputs active, let us see what it is doing. Look at this. In this IN0, 1, 2, 3, 4, 5, 6, 7, we are having 8 inputs. In the 8 inputs, you look at IN1 is active and IN2 is active. Here, 2 inputs are active. That is IN2 and IN1. So, it takes the higher priority one, the most significant bit. So, it takes IN2 and the output it will give us 0, 1, 0. That is the binary of 2. And let's see the next example. Look at this. In this 8 inputs, IN3, IN4 and IN6, 3 are high. So, here it takes the highest priority one, that is IN6, and the output will be 110, the binary of 6. So, this is the concept how it is taking, that is selecting the higher priority one as a output. Now, let's go into the code, and when we are seeing the final output, we will be clearly understanding this priority encoder. So, now let's first start the RTL code. RTL code. Look at this. 8:3 priority encoder. We are writing the RTL code. First, we are giving the module and the module name. The module name which I have given here is priority underscore encoder 3 to 8, and I have opened the bracket. After opening the bracket, we need to give the inputs and outputs. So the first, we have given the 8 input lines, that is 0 to 7. And next one, we have given the 3-bit output, and I have given it as out, and 0 to 2, and it is stored in the reg. After assigning the inputs and outputs, we are closing the bracket. The next, we are going to start the logical operation. Yeah, here it starts a combinational always block that executes whenever any input changes. And this default output comment indicating initialization of output. Next, out is equal to 3-bit binary 000. This one, it sets default output to 000 used when no higher priority condition is met. And this comment is indicating priority checking starts from most significant bit, that is IN7. And if IN is 7, out is equal to 3-bit binary 111. This is if IN7 is high, then the output is 111, the binary of 7. it is having the higher priority and it will be selected. The next one is else if IN6 out is equal to 3 binary 110. This is telling that if this input 7 is low and IN6 is high means the output is 110. That is the binary of 6. And if 7 is high and 6 is also high means the higher priority will be given to the 7. If 7 is low and 6 is high means the higher priority will be taken by the IN6. And in the next condition, else if the higher bits are low and IN5 is high, the output is 101. That is the binary of 5. The next condition tells us that if IN4 is the highest priority one, then the output is 100. That is the binary of 4. And if IN3 is the highest active, then the output is 011, the binary of 3. And if IN2 is the highest active, then the output is 010, binary of 2. And if IN1 is the highest active, the output is 001, that is the binary of 1. And the next condition is if IN0 is high, the output is 000, binary of 0. And then it ends the always block and then it ends the module. This is the RTL code of 8:3 priority encoder. Now let's see the test bench of it. This is the test bench of 8:3 priority encoder. First thing is we are starting it with the module and the module name. After that we are going to assign the inputs and outputs using reg and wire. First you see we have assigned the input, that is 8 input line using the reg, and then we are assigned the output using the wire. After assigning the inputs and outputs, obviously we need to instantiate the module inside the test bench. So instantiating the module inside the test bench. So we are giving the module name and UUT, that is unit under test, and opening the bracket, and then test bench IN is connected with the module IN, and test bench out is connected with the module out, and we are going to close the instantiation. The very basic steps we need to do is we are going to assign the input and output using reg and wire, and then we are going to instantiate the module into the test bench. After doing this, we are going to start the operation by initial begin. This apply test vector command, it indicates different input test cases will be applied. So we are going to apply different test cases. The first thing we are going to apply is IN is equal to 8-bit binary 0000001. That is, it activates only IN 0 and waits for 10 time units before next input. And the next one is it activates only IN1 and waits 10 time units. And next one, it activates only IN2 and waits for 10 time units. Next one, it activates only IN3 and waits for 10 time units. And the next one, it activates only IN4 and it waits for 10 time units. The next one you look, it activates only IN5 and waits for next time unit. And the next one, it activates only IN6 and it waits for the next time unit. And the next one, it activates only IN7 and this is the highest priority one, and then it waits for next 10 time units. And look at this. The next condition is here all we have seen only one condition is high. And here you see multiple inputs are active. That is in is equal to 8 binary 0 1 0 1 0 1 0 0 0. We are giving totally 3 input conditions active. That is in6, in4 and in2. And the encoder should output the highest priority one. In this we know that in in2, in4 and in6, in6 is the highest priority one. So the output must give the in6 and it waits for 10 time units. And next condition we are giving as in 8-bit binary. Everything we are doing it as 0. And this 0, what it means all inputs are low. The output will remain default 0 0 0 and then it waits for 10 time units and then it finishes the simulation and ends it and ends the test bench. So this is the test bench of 8:3 priority encoder. Now let's see the output wave. Yeah, students, now we are going to see the 8:3 priority encoder output waveform. Look at this. This is the waveform. Here we have inputs and bottom we have outputs. Let's see all these. First condition, our test cases we are going to give. Our test cases, first thing is in0, in1, in2, in3, in4, in5, in6, in7. These are all inputs. And in the first test case, we have given that in0 is active. When in0 is high, the output is 0, 0, 0, the binary of 0. So look at here, when in0 is active, that is 1, the output is 0, 0, 0. And then when in1 is high, the output is 0, 0, 1. That is binary of 1. That is when the input 1, in1 is active. You look at this, our output is 0, 0, 1. And in the next case, you see in2 is active. When in2 is high, the output is 0, 1, 0. in2 is active, output is 0, 1, 0. Similarly, in the next case, when in3 is high, the output is 0, 1, 1. When in3 is 1, 0, 1, 1. Then when in4 is high, the output is 1, 0, 0. See, when in4 is 1, it is 1, 0, 0. And you see here, when in5 is high, the output is 1, 0, 1. When in5 is 1, 1, 0, 1. And then when in6 is high, output is 1, 1, 0. When in6 is high, output is 1, 1, 0. Then when in7 is high, output is 1, 1, 1. When in7 is high, output is 1, 1, 1. And next case you see, in the previous case we have seen only one of the input is high. But here you see 3 inputs are high. In the priority encoder, many inputs can be high. Here in2 is high, in4 is high and in6 is high. So in this it will choose the most priority one. The most priority one is in6. So it will be choosing 1, 1, 0. So you see here in6 is active and in4 is high and in2 is also high. So it will choose the higher priority one. The priority one is in6 and that is 1, 1, 0. 1, 1, 0. That is 6. And you see in the next class, the final test case we have given us, everything is 0. So no input is high, output is 0, 0, 0. So you see no input is high and the output is 0, 0, 0. So students, we have seen 8:3 priority encoder today. And next we are going to learn decoder, comparator, arithmetic and logic unit and many more RTL codings we are going to learn. If you want to learn it from the scratch, please subscribe my channel VLSI with Dr. Leena.